Okay, good morning class. So today we're looking at the homework of functions and inverse functions. We're looking at exercise 2. We have selected a few sums that I wanted you to do for homework. Okay, or we had a few sums that you had to omit from this exercise. So exercise 2 is on page 39. So here we are told that for each function f of x drawn below, copy the graph and give the function and use it. Okay. Copy the graph of the given function and use it to sketch the graph of the inverse on the same axis. Okay, so let's do that part first. So if I take this graph, which is 1 and 0 becomes 0 and 1. And 0 and minus 3 becomes minus 3 and 0. So let's draw this graph here. This is the inverse function. Okay. Draw the line y is equal to x. Going through the origin there, y is equal to x. Write down the equation of the inverse in that form. What do you do for the inverse function? We interchange x and y. Not so. So it becomes x is equal to 3y minus 3. So 3y is equal to x plus 3 divided by 3, so y is a third x plus 1. You will agree with that? Write down the domain and the range of the function and its inverse. The domain and the range of the function, x is an element of all real numbers, y is an element of all real numbers. The range of the inverse function and the domain of the inverse function. The inverse function, x is an element of all real numbers, and the range, y is an element of all real numbers. Are there any problems there with the homework? Sorry? So no problems. Alright. Let's look at the next one. Number 2. 1.2. So again, you have to copy the graph and draw the inverse function. So 3 and 0 becomes 0 and 3, which is midway between 6 and 0. 0 and 6 becomes 6 and 0. So there is the inverse function. Now so, draw the line y is equal to x, will be a line going through like that. Going through the point of contact there. Again, like there, the graph is going through that point of contact. Why? So those points is where the graphs are equal to each other. And the x value is equal to the y value there. So this is y is equal to x. Write down the equation of the inverse. What do you do for the inverse function? Interchange x and y. Not so. So what do we have? X is equal to minus 2y plus 6. They get over the equal sign. So 2y is equal to x minus x plus 6 divided by 2, so y is equal to half x plus 3. Which confirms that y-intercept. Okay. What's the domain and the range of the function? X is an element of all real numbers, x is not, and y is an element of all real numbers. The domain of the inverse function, x is an element of all real numbers. The range, y is an element of all real numbers. Yes. Sorry? Yeah, negative. Yeah. Sorry about that. I divided throughout by 2 here. The negative I didn't do. Thank you. Anything else? Here's more. Clear this here. Again, we must draw the inverse function. So 0 and 0 remains 0 and 0. 1 and minus 3 becomes minus 3 and 1. Minus 3 and minus 1 minus 3 becomes minus 3 and minus 1. So we draw the inverse thing. Draw the line y is equal to x, and we'll go through here. Okay. The equation of this graph for the inverse function, what do? We interchange x and y, not so. So, we have x is equal to minus 3y squared. So to get y squared on its own, I divide by negative 3 both sides. Negative 3, not a third, that's 3, no? So y squared is equal to negative a third x. So to get rid of the square, I square root both sides. What must I not forget? Plus minus. So y is equal to plus minus the square root of negative a third x. And you can see here that x is less than 0 here. Can you see me? Because x is less than 0, that negative that comes from here times this negative will always be a positive, and the square root of a positive. In the solution, I would assume that they have x is less than 0 there as well. You should have. Okay. Why? Because that has to be positive. But they wouldn't penalize you if you don't write it in. Unless they ask you the restriction. Okay. This is write down the domain. This is now D. Domain of the function, the range of the function. Domain of the inverse function and the range of the inverse function. So the domain of if is, it goes negative infinity, positive infinity. So x is an element of all real numbers. What about the range? Reading it from the negative, where does it stop existing at? 0. So in other words, y must be less than or equal to 0. Let's look at the domain of the inverse function. Domain, this is the inverse function. X has to be less than 0. Less than or equal to 0. What's the range? This goes negative infinity, positive infinity. Okay? So y is an element of all real numbers. What do you notice? The domain of the function becomes the range of the inverse function. Can you see that? Well, so the range of the function becomes the domain of the inverse function. Okay, you couldn't have seen it in the previous two because the domain and the range is both x was an element of all real numbers and y was an element of all real numbers. Okay. Let's look at the next one. Okay, this is not part of your coursework, but I said I was going to do it anyway. So first question, copy, draw the inverse function. So 1 and 0 becomes 0 and 1 becomes 1 and 0. 2 and 5 becomes 5 and 2. Okay, this mustn't be. Okay, I'm going to try and get to do it. And then minus 2 and 5 becomes 5 and minus. From the turning point that draw. So this is the inverse graph. Okay. So what they want me to draw in afterwards is the line y is equal to x. So if I fold this graph close in this line of y is equal to x, you'll see that that part will fall exactly onto this graph. Okay? What they want you to calculate thereafter? They want you to work out the inverse function, not so. What do I do for the inverse function? I interchange x and y. So x is equal to y squared plus 1. Get y squared on its own. So y squared is equal to x minus 1. Okay, so what do I do now? Square root. If I introduce square root, plus minus. Y is equal to plus minus the square root of x minus 1. Okay? You agree with that? So what do we do thereafter? Write down the domain. Domain of function, range of function. What's my domain of the function? Goes to positive infinity and negative infinity. So x is an element of all real numbers. The range. That this graph exists at negative infinity. Now where does it start existing at? 1 onwards. So y is greater than or equal to 1. Domain of the function, sorry, the inverse and the range of the inverse function. So as you can see here, the domain of this function. Does this graph exist at negative infinity? No, where does it start existing at? 1 onwards. So x is greater than or equal to 1. What about the range? Negative infinity, positive infinity. So y is an element of all real numbers. Again, you can see that relationship that exists between those two. Okay. Any questions? No? Number 2. Number 2, the graphs of f of x equal to x squared and negative x squared and g of x is equal to negative 2x minus 3 are sketched below. A and B are points of intersection of f and g. Let's go to the first question. What's wrong? Boy? Now why are you talking? You make me nervous. Did I make a mistake?
Yes.
Nothing is wrong. I mustn't talk. I mean, I like talking. I feel cheated on. Alright. Determine the coordinates of A and B. People, how do we calculate A and B? The points of intersection. How do we calculate points of intersection? So the two graphs equal to each other. So it's going to be negative x squared equals negative 2x minus 3. So 0 is equal to x squared minus 2x minus 3. Trinomial. Either that or complete the square or quadratic formula or use the calculator. No? There's many options to you. So minus plus. So x is equal to 3 or people, why are there two values? 2 points of intersection. Can you see that? So what I do is I sub that either into your f of x or g of x. F is going to be the easier one to me at this point. So negative 3 squared, which is negative 9. So it's going to be 3 and negative 9, which is your b. Can you see that, people? X is positive, whilst y is a negative value there. On the other hand, you say f of 1 negative 1 squared is negative 1. So it's negative 1 and negative 1, which is your a. Would you have an easier method that you're telling them about? Huh? I know you did the sections already. Done one. Huh? Is the master this already? No? I should have asked you a couple of questions. But don't worry, logs is still coming. No, but that's easier than this. Then again, everything is easy. People? So there we go. Determine the equation of the inverse of g in that form. Right, so what do I do for the inverse? The inverse function, what do I do? Interchange x and y. It's on the g graph. So I'm not going to go with f, no? G. So it's going to be x is equal to minus 2y minus 3. Remember, g of x is a y. So we take it over the equal sign. So minus 2y is equal to x plus 3. divided by negative 2. So it's negative half x minus 3 over 2. Or x over negative 2. It's the same as negative half x. And that is the inverse function. I'm going to write it here. So I'm going to clear the board now. Okay, any issues here? Am I still on the right path? I must make sure that maybe I made a mistake somewhere. Sorry? What do you say? Marjan. Okay, Marjan. You like to take over? Huh? Not yet, okay? You tell me when you're ready. Determine the equation of the inverse of f in that form. People, what we do for the inverse of f? We interchange x and y. So that's your y. So x is equal to minus y squared divided by negative 1 both sides. So y squared is equal to negative x. How do I get y on its own? Square root. If I introduce square root, so y is equal to plus minus the square root of negative x. But x has to be less than or equal to 0. No? Why? Because if it's less than 0, it's going to be negative. And negative times a negative is a positive. Okay, so as I said, times they won't penalize you there unless they ask you for the restriction. People, is this a function? Boy? Will it be a function? Remember that is the inverse of f. It will go this way. Why would it not be a function? Does not pass. Does not pass the vertical line test. 2.4. Give a reason why the oh my word. I ask you exactly that. Give a reason why not the function and place a restriction on the domain of f so that its inverse can be a function. Okay? So 2.4, why is it not the function? Does not pass the vertical line test. And how can we restrict the domain so that the inverse can be a function? If we take that into account and we reflect this graph, okay, it will do that. Not so. So is this inverse a function? Yes. So how could that be restricted? X has to be less than or equal to 0 or x has to be more than equal. People, even if you don't understand it, and they ask you this question, it should ring a bell. They talk about parabola. This is the answer there. 2 marks, always. Okay. We spoke about that in our previous lesson as well. People, beautiful some here. I like to see these ones. Then again, I like old times. You know, you guys remember like old times. Huh? Just hoping you can make it through this year. You see, with that mindset, you're experiencing maths like that. I can't go sleep at night without doing a couple of sums. No? So in the holiday, I just have a lot of geometry books that I just do geometry. Yeah? Otherwise, it's not a holiday. No? People, 2.5. Show that g of x plus 2f of 1 over x plus 3 is equal to 2 over f of x minus g of minus x minus 3. What do we do here? For 5 marks? Skip. No? not to die. People, this is an identity. We must prove that the left hand side is equal to the right hand side. So this is the left hand side of the equal side. So you say LHS equals. So what is g of x? So g of x is negative 2x minus 3. Not so. So this is this part. So it's going to be 2 minus 2x minus 3 plus twice f of 1 of x. Now f of x is defined as negative x squared. So f of 1 over x, you see this part here, It's going to be, if I see x up at 1 over x. So it's negative 1 over x squared. Not so. And with a 2 in front, it's 2 times whatever f of 1 over x is. So it's negative 2 into 1 over x whole squared. You see that? So let's put that in. So it will be minus 2 into 1 over x squared. I'm sure you guys can do this in your head. Huh? I'm just showing myself how to do it. Okay. Plus 3. So what do we got now? It's negative 2x. That 3 and that 3 cancels. Minus 2 over x squared. Because that is going to be 1 over x squared times negative 2. Negative 2 over x squared. Right. Now we go with the right hand side. So if the right hand side is also the same as this, we've done the job. So let's go. People, f of x is negative x squared. So 2 over x, f of x, is 2 over negative x squared. Okay, which is this part here. So it's 2 over negative x squared. Which is that there? Not so. Now, what is g of x? So g of x is negative 2x minus 3. What is g of negative x? So if I see x up at negative x. So it's negative 2 into negative x minus 3. And with that negative in front of that there, this whole thing must have a negative in front of it. That's all? Am I right, boy? Yeah? This is yes, alright? I'm feeling better about myself? Let's see. People, so what do we have? Negative into negative 2 into negative x minus 3, which is that part there. Minus 3. Let's go. So that's simply going to give us negative 2 over x squared minus 2, a negative minus, that's going to give you a positive 2x now, not so. Now multiply that out, I get 2x minus 3 minus 3. Get rid of the brackets. So minus 2 over x squared minus 2x plus 3 minus 3. So hang on. It's gone. So it's negative 2 over x squared minus 2x. But is that not the same? Which is equal to the left hand side. And never again are we going to skip that question. No? Definitely in your upcoming cycle test. Not this one. So, writing 4 weeks time. Okay. 2 weeks before you write your mock exam. Don't blow so it's already hot in here. Right, so people number 3. Given that f of x equal to negative a third x squared and g of x equal to negative a third x, one is parabola and one is a linear function with straight line. Sketch a graph of f and g clearly showing the points of 3 and okay, let's do it. And I go with f of x first. We will put 3 into here. Okay, what did I say? I was going to draw that graph, no? That table. But if I put 3 in here, so the table that they almost enforcing on us is negative 3, 0 and 3. So if x is 3, I must get this value here. So f of 3 is going to be 3 squared, which is 9. And 9 times negative a third is negative 3. 0 is 0, and negative 3 is negative 3. So it's 1, 2, 3. 1, 2, 3 negative, and 1, 2, 3 minus 1. Okay, so this is your f of x. This is 3 and minus 3. Now you see this f of 3 is the answer of f of x at 3. Okay. That's minus 3 and minus 3. Okay. And then of course the other graph, which is the g of x is equal to negative third x. So we will draw that. X and y. So they want you to use 3 again, so I'm going to go with the same values. So g of 3 is going to be negative 1, 0 and 1. So you've got minus 3 and 1. So here we've got minus 3 and 1. 0 and 0. And 3 and minus 1. Again with the ruler, we draw that line. Okay. This is the graph of G. This is the graph of P. Why did you read it? The graph of G. Okay. Looks like this is actually going through 1 here, no? But a graph is not drawn to scale. But I'm sure you guys will do much better than me in terms of the scale of the graph. Okay. People, let's look at the next question. This is write down the equation of the inverse of f and g. So the inverse of f and g. So for the inverse of f, let's go with f first. What do? We interchange x and y. Not so. So x is equal to negative a third y squared. So I divide both sides by negative a third. So 1 divided by negative third is negative 3 is equal to y squared. So what do I do now? Square root. Do not forget plus minus. So y is equal to plus minus the square root of negative 3x. So what do we know about x here? X must be negative. Otherwise you will have a negative under here. So this is the inverse of f. Okay, let's look at the inverse of g. Again we interchange x and y. So you say x is equal to negative a third y. Divide both sides by negative a third. So y is equal to negative 3x. And this is the inverse function of g. Again, note here that I don't put f of minus 1 here. Why? Because that's not a function. Okay. 3.3. About which line is f and the inverse symmetrical? About the line y is equal to x. Draw the graphs of f, the inverse of the same set of axes as f. So we're going to draw this. The inverse of f. So 0 and 0 remains 0 and 0. 3 and minus 3 becomes minus 3 and 3, which is this point here. Not so. And then 3 and minus 3, no. Minus 3 and minus 3 remains minus 3 and when you swap that around. And 3 and minus 3 becomes minus 3 and 3, which is this point here. And there's that graph. This is the inverse. Okay. So what we normally go in is the line. Y is equal to x. And as you can see here, this part of the graph represents that there, whilst that is represented there. We are folded close in that line. Okay. See any confusion? Is this inverse a function? No. How can we restrict the function so that its inverse can be a function? X is less than or equal to 0 or x is more than or equal to 0. Oh my word. Exactly those questions. You see the questions just get repeated all the time. Explain why the inverse is not a function. Does not pass the vertical line. Indicate how, in which way would the domain of the function be restricted that the inverse can be a function. X is less than or equal to 0 or x is more than or equal to 0. You see the same thing over and over. That's why I left it for last. Nice, so too easy for words. Yes, another question. People, number 4. We are given f of x equal to half x squared and g of x equal to 2x plus 4. Is f of x a function? Give a reason for your answer. Is f of x a function?
Yes.
Yes. Why?
Possible.
Was the vertical like this. Okay. And what type of function is that? Parabola. Many to one, one to many, many. Not O. O is 0. Is none of it. Yeah. Alright, so what type of function is this? Yes! Many to one. Jeez Louise. Right, 4.2. Write down the domain and the range. People, what I would do is I'll draw the function for them. Okay. So let's go with f. So what do? Is I draw so x and y. I choose -1, 0, 1. So that gives me, so I'll rather go with 2. So that I don't work with fractions. Okay. If you had gone with -1, 0 and 1, I would have gotten a half, 0 and a half. But because I'm going with 2, 2 squared is of course 4, which gives me 2. 0 and 2. Okay, so this is your, so it's 1, 2, minus 1, minus 2. Minus 1 minus 2. Okay, so minus 2 and 2. Again, this wasn't the question, but it would just make life so much easier for me if I drew it. And you do the same in the exam. If they don't ask you, you just do it on the side. Okay? So this is the function. So what do we do for the inverse function? We interchange x and y. So 0 and 0 remains 0 and 0. This was 2 and 2, it remains 2 and 2, and minus 2 and 2 becomes 2 and minus 2. From the turning point, okay, and this is the inverse. It's not the function, but okay. So let's say, write down the domain of f of x and the inverse. Right. Write down the domain of f of x for the So in other words, how would you restrict the domain of the function so that the inverse can be a function? Not so, people? So how can we restrict? Is this inverse a function? No. Why? That's not possible like this. So how can we restrict the domain of the function so that inverse can be a function? X is less than or equal to 0 or okay. 4.3. Write down the equation of the inverse of g. Write down the equation of the inverse of g. So what is the equation of g of x? 2x plus 4. G of x is equal to 2x plus 4. So what do we do for the inverse function? We interchange. We interchange x and y. So x is equal to 2y plus 4. Make y the subject of the formula. So 2y is equal to x minus 4 divided by 2. So half x minus 2. That is the inverse of g. Write down the range of f. The range of f. This is f of x. Not so. What is the range? Does this graph exist at negative infinity? Where does it start existing at? 0 onwards. So 4.4, y is to be more than or equal to 0. Question 5. The graph of f of x equals ax squared, where a is less than or equal to 0, which means to say it's only this part of the graph here that's represented. Okay? Alongside the point a, which is negative 2 and 5, lies on f. Determine the value of a. People, how many unknowns are here? 1. So that's the one I must calculate. I need 1 point on the graph. Okay, we have actually 2, but 0 is not going to make a difference to us. So what we do is we substitute the point lying on this graph, which is a, negative 2 and 5. You substitute it into f of x equals ax squared. That's the x and the y. So 5 is equal to, remember f of x is the y, a into negative 2 squared. Negative 2 squared is 4. So a is equal to 5 over 5.2. My equation now reads f of x is equal to 5 over 4x squared, where x is less than 0. Determine the equation of the inverse. So if I draw the inverse function, 0 and 0 remains 0 and 0. 5, negative 2 and 5 becomes 5 and negative 2. Not so. If that was the question, this is not the question. So is that inverse a function? Yes, why? Pass the vertical line. Okay, but anyway, determine the inverse function. So what do we do for the inverse? Interchange x and y. So x is equal to 5 over 4 y squared. So what do I do now? But remember, when I take the inverse function, the what's the name changes, no? The inequality changes from x is less than 0 to x is more than or equal to 0. Okay. So I divide both sides by 5 over 4, so it becomes 4 over 5x is equal to y squared. So what do I do now? Square it. If I introduce square root, plus minus. So y is equal to plus minus the square root of 4 over 5. Okay, where x is also greater than or equal to 0. Okay. Any confusion there? No? 5.3. 5.3 says write down the domain and the range of the inverse function. Write down the domain and the range of the inverse function. So the inverse function, as you can see here, that's the inverse function. Not so. What's the domain that this graph exists at? Negative infinity. No. Where does start existing at? 0 onwards. So the domain of the inverse would be x is more than or equal to 0. What's the range? The range is all possible y values. Does this graph exist at negative infinity? Yes. Where does stop existing at? 0. So in other words, it's less than. So y is less than or equal to 0. 5.4. Copy the graph of f onto a set of axes and draw the graph of the inverse function, which is this one here, on the same set of axes. Show the coordinates of 2 points on the graph of it. So there I got 0, which is the one, and 5 and negative 2 is the other point. Okay. But what do you notice? I find it easier to use it like this, to read it off from the graph. Instead of remembering all the theory, just use the graphs, it's easier for us. Okay. But if you're that kind of girl that wants to know all the theory, so be it. Okay. 5.5. If the graph of f is reflected in the y-axis, if the graph of f is reflected in the y-axis, what is the equation of f of x? 5 over 4x squared. Y is equal to 5 over 4x squared for x is less than or equal to 0. Okay. So the question says, I'm going to do it with a drawing. So this is, was it negative 2 and 5, no? What was it? So here, if the graph of x is reflected in the y-axis, which means to say now what? That the graph is going to come that way through now, not so. So that is going to be 2 and 5 now. Alright? So if the graph is reflected in the y-axis, what's the rule? Something reflected in the y-axis, x becomes negative. If it's reflected in the x-axis, y becomes negative. Reflected in the y-axis, x becomes negative. So it's y is equal to 5 over 4 negative x all squared. But remember, if that is now x becomes negative, that must also become negative. Not so. Divide by negative both sides. X must now be more than or equal to 0, which confirms this here. Okay? So x is more than or equal to 0. So the equation now reads y is equal to 5 over 4 x squared. Why? So negative x all squared remains positive x squared. Okay? And this is for x is greater than or equal to 0. Then reflected in the line y is equal to x. People, something reflected in the line y is equal to x, what happens? This is actually your inverse function. Not so. So that is simple, that it becomes x is equal to 5 over 4 y squared. And that we worked out already. That's going to give us y is equal to 4 over 5 x the square root thereof. Okay, good. Need to check something quickly. It's coming back here, the inverse function. I made a mistake here, no? Because I said plus minus here, which is fine. But if we look at this graph here, what do you notice? We only have the negative solution. Can you see that? We had plus and minus, that would be plus and this would be minus here. So it's only minus. Sorry about that. Again, why is it only the minus 1? Because that's the one below the axis. If it goes plus, it would have been the one above the x-axis. Okay? Just realize now when I'm speaking about this one here. Okay? So if you introduce square root, of course plus minus. So therefore, so if I reflect this point, which is 5 and 2, 2 and 5 becomes 5 and 2, which is this part of the graph. Which means to say this has to be the positive or the negative one? The positive one. Therefore y is equal to the square root of 4 over 5x, where x is greater than or equal to 0. Okay. Beautiful, son. People's question 6.1. If f of x is the inverse of g, if f of g of x is equal to f of x is equal to x, use the statement to test whether f of x and g of x are inverse. People, this is not part of your curriculum, okay? But I'm going to do it anyway. So they want, if you can prove that that is equal to that, is equal to x, you've done the job. You're the inverse function. Okay. So we substitute. So we say f of g of x, the left hand side of course. Okay, so that's going to give you f of, what is g of x? X minus 6 over 5. So in other words, we now going to work out what is f of x minus 6 over 5. So we put that into here. So it's going to give us, if I see a x, I replace it with x minus 6 over 5. Which now gives us cancel x minus 6 plus 6, which gives you x. Okay, but is that enough? No. So we must do the right hand side. Equals g of f of x. So we go g. What is f of x? 5x minus 6. 5x minus 6. Is it plus 6? 5x plus 6. Okay, so wherever I see in g of x, wherever I see a x, I replace it now with 5x plus 6. So there's a x. So you get 5x plus 6 minus 6 over 5. That cancels. Gives you a 5x over 5, which is, say, hang on, same. So we say, since, state the obvious, since f of g of x is equal to g of f of x, which is equal to x. Therefore, f and g are functions. They have, if They are inverse functions to each other. Okay? Let's look at 6 by, I think this is 2. Yeah. There is 5 or 4 in the textbook. So I just, as I said, it's not part of your syllabus anyway, so this for enrichment purposes. So let's go left hand side is equal to f of g of x. So what is g of x? That's stored here. So it's 2, sorry. What is g of x? G of x is plus minus the square root of x plus 1 over 2. So if I see now x in f of x, I replace it with the stored here. So it's 2 into plus minus the square root of x plus 1 over 2 all squared minus 1. Now from a square you'll never get a negative. Okay? Because a negative times negative is positive. So in other words it will be 2 into. That cancels. That also cancels with the square. So I'm left with x plus 1 over 2 minus 1. That cancels. Which is x plus 1 minus 1, which is x. You see what happens on the right hand side. The right hand side. The right hand side says g of f of x. So g of f of x is of course 2x squared minus 1. Okay? So now it gives you, if I say x, I put the 2x squared minus 1. So that's plus minus the square root of 2x squared minus 1 plus 1 over 2. That cancels. So it's plus minus the square root of, that cancels, x squared, which gives you plus minus x. So is that the same? No. So therefore it's not a function. They're not inverse functions to each other. Let's check what's the answer at the back. I would assume they would do what would they have wanted if they had gotten x on both sides. Let's check it. The positive one would be the x, but the negative is the one that's. Sorry? Sorry? 6.2. Yeah, the one on the phone. Yeah, I think they changed it. Reason? Yeah, not inverses. It's because of that minus x. The plus minus, can you see that? That minus x is the one that omits the fact that it's going to be inverse functions. I think they had it first as functions, but somebody probably pointed it out to them. Okay, so they had to fix their mistake. But that's how it goes, no? When you guys write your own textbook, probably not for maths, because you want to get out of it. But for whatever, we'll see that there's going to be changes. People, that basically brings us to the end of the chapter on inverse functions. Okay, so from here we're going to logs and exponential functions. The full lesson can be found in the description box below.